Section 3 still starts dealing with multiplication of exponents, but we're talking about multiplication properties of exponents. We've already learned one. When we have like bases and we're multiplying them, we add our exponents. There's a couple more that we're going to learn in this section. So here we go. Simplify the following expressions. We have 4 to the 5th to the 3rd power. So I guess I could figure out what 4 to the 5th is first. Probably something kind of big. And then raise that big number to the 3rd power, which is going to give me a really big number. I don't want to deal with that. What I want to do, actually, is remember what exponents mean. What do exponents tell me? How many times I'm multiplying something times itself, right? So in this case, I'm multiplying 4 to the 5th times itself. How many times? 3 times. So I'm going to write that out as 4 to the 5th times 4 to the 5th times 4 to the 5th. Yeah, that's right. These are all like bases. 4, 4, 4. Those are all like bases, and we're multiplying those together. How do I handle multiplying like bases? We add the exponents. So 5 plus 5 plus 5 is 15. So this actually turns into 4 to the 15th power. Whatever that is, something really big. So I'm just going to leave it as 4 to the 15th power. Yeah, it's really big. It's probably bigger than billions, I'd say. Did you actually find it? It's pretty big. It is in the billions? Oh yeah, way too big. I don't even want to, that makes my head hurt. So what should I do with this second one here, this 3 to the 6th to the 4th? 3 to the 6th times itself 4 times, that's right. Okay, so now I can see that those are all like bases. So what should I do? Add the exponents and we get 3 to the 24th. How about x to the 4th squared? What should I write? Good. And that gives me x to the 8th. And how about this last one? X to the 3rd 3 times. X to the 3rd times x to the 3rd times x to the 3rd. We add the exponents and we get x to the 9th. All right, now at the bottom it says each of these examples raises what I call powers to a power. I raise an exponent to another exponent. What happens? We multiply the exponents. Yep. We have 4 to the 5th to the 3rd, and we wound up with 4 to the 15th. We have x to the 4th squared, and we wound up with x to the 8th. We have 3 to the 6th to the 4th, and we wound up with 3 to the 24th. We have x to the 3rd, and we wound up with x to the 9th. What happened each time? We multiplied the exponents. What happened to the base? It stays the same. So there's your next rule. And actually, you saw it, or some of you saw it, which means you actually learned the rule before I even taught it to you, which is pretty cool. So here is the rule, raising a power to a power. And you'll hear me say that a lot. If I'm raising a power to a power, what do I do to the exponents? Well, I multiply them. So the algebra, the formal notation here, says if I have some base to a power, and then I raise that to a power, then I just have that same base, and then m times n in my exponent. That's all that's trying to tell you. Again, a can't be equal to 0, and we've talked about that before. M and n are rational numbers. What are rational numbers again? Fractions and integers. The word ratio is in rational. That's a fraction or an integer. So as long as you have fractions or integers, you can raise the power to a power. You can multiply them together. So the examples 5 to the 4th squared becomes 5 to the 8th. M to the 3rd to the 5th becomes m to the 15th. We're just multiplying. Over here, a to the 3 halves to the 3rd. How do we handle that? Way back in August, We learned how to multiply fractions. We multiply straight across. So this is like a 3 over 1 here. And then I multiply across. 3 times 3 is 9. 2 times 1 is 2. So this becomes a to the 9 halves. It doesn't matter that it's a fraction exponent. We can still do that same rule. Here we have, I can't read that. What is that? X to the 1 half? Yeah. X to the 1 half to the 3/5. Okay. So what do? Multiply across. 3 times 1 is 3. 2 times 5 is 10. We wound up with x to the 3/10 as our answer. Okay, so let's see if we can kind of maybe quickly do these 6 problems right here. What will we get for that first one? 4 times 7? Yeah, it's 28. So n to the 28th is the answer. How about this one? P to the 20th. How about this one? P to the 20th. How about this one? X squared. Good, because we multiply across. 2 times 3 is 6. 3 times 1 is 3. 6/3 reduces to just x squared. How about the next one? P squared. Good. And the last one? Y to the first, which is just y. So once you know that rule, you can do these problems fairly quickly, which is really nice. Okay, so that's the basis for what we're doing in this section. Now the problems are going to be a little bit more challenging. There's just a little bit more you have to do in these problems. Simplifying an expression with powers. To simplify these, take care of the powers to powers first. Take care of what we just learned how to do first. Then multiply like bases. So like what we did in the last section. Okay? Exponents comes before multiplication. Keep that in mind. So in this case, we have an exponent. That's got to happen before the multiplication. We're used to seeing numbers in here when we're working with order of operations, but they don't have to be numbers. It's still exponents first and then multiplication. So how do I handle this exponent? Notice that this is a power to a power. So how do I handle powers to powers? We multiply. So I'm not doing anything to this y to the third right now, so I leave it alone. But this turns into what? Five halves times -2. Put that over 1 so that I can multiply across. And I get 5 times -2, which is -10. 2 times 1, which is 2. So this turns into y to the -10 halves, which is actually -5. Oh, okay, now what do we do? Yep, we have multiplying like bases here, so that means we're going to add our exponents, and we get y to the -2nd power. This has really gotten simplified. Are we done? No. How come we're not done? Yeah, we have a negative exponent, so we got to take care of that. What will I write as my answer? 1 over y to the 2nd. Very good. There's your answer. Okay, so notice we did this first. Then we could do the like bases and add the exponents. And then we simplified from there. So let's see if we can do the next one. It's very similar. What will we do first? Yep, powers to powers. Got to take care of that first. So what will I write? X squared. That's not plus. That's times. X to the -24th power. Good. Now what? X to the -22nd power once we add these exponents because we're multiplying like bases. We got a negative exponent on our answer, and that's a bummer, so we got to take care of it. We write, and there's your answer. Okay, the bottom two are very similar to the top two. See if you can handle those. So what do we need to do first on that W one? Exponents. Powers to powers, multiply your exponents, that's right. So what do we get? Well, we have the W to the negative second out front still, times W to the, well, 5/3 times 3 over 1 is actually 15/3, which becomes 5. It reduces to 5. Okay, now what? Those are like bases being multiplied, so we add the exponents and we get W to the third. Do I need to put that under 1? No, there's no negative exponent here, so that's your answer. That's as far as you can go. Okay, the last one looks pretty tricky. What do we need to do first? Put the negative 5 over 1, and then, good. This is powers to a power here. We're raising a power to a power, which means we multiply the exponents. And when we do that, we get s to the what? Positive or negative? That is a negative times a negative, which is a positive. 5 halves. We still have the times s to the 3 halves, though. Now we add exponents because we're multiplying like bases. So what is 5 halves plus 3 halves? Yeah, think of it this way. Say it this way in your head. 5 halves plus 3 halves is 8 halves, which reduces to 4. So this is s to the 4th, and that's your answer. So pay attention to what you're doing. Powers to powers first. Then you can take care of the multiplying like bases, which means you add the exponents. 10 through 21 odd, you're capable of doing those. That's 6 problems or something. Give those a shot.